Here we see that the call is now to subprogram 1, tab 3. So let's go to subprogram 1. Subprogram 1, we see a little bit of mathematics going on here. So instead of doing it here, we're going to go to the trail and see what happens. So we'll execute the application and go to the trail. We're going to go through the instructions on the trail, but we want to see what the values of these different registers are. So we're going to say we want to look at the data. Here is the data. Here are the registers it's talking about, A, B, C, D, E through H. And we notice down here it says these are the registers for subprogram 1. Now let's go see the math that's being performed. First A is set to 10, and then we add 5 to A. Well, we go down here and said yes, A ended up being 15. Here we set B to 25, and we subtracted A, which is 15, from it, so B is 10. Then we set C to 2 and multiplied it by 2 plus B. Well, B is 10, so 2 plus B is 12. C was 2, we multiplied it by 12, it's now 24. Then we see we set D to 60. Now, we got to advance the trail. We know D is 60, and it's going to be divided by C, which is 24. Now, this division here is integer division. So the number of 24s in 60 is 2. So D is equal to 2. Then we set E to 60, and we divide it by the same value of C, which is 24. But this is a floating point division. So the value of C is 2.5. Now you notice here it says 25, but it's followed by an A, which means shift the decimal point to the left 1. So E is 2.5. Then we say set F to 60 and get the mod of it when divided by C. That means the remainder. Well, 2 times 24 is 48. 48 to 60 is 12. So the remainder is 12. Then we set G to the negative of 12. G is minus 12. Then we set H to the absolute value of minus 12. So H becomes 12. Then, of course, we go back to main program and exit. That's the end of the trail. Now the main program is set to go to tab 4 of subprogram 1, where we find a wrap instruction that says that M is supposed to go from 0, 1, 2, 3, 4, 5 up to 15. Once it gets to 16, it becomes 0 again, and it goes from 0 to 15 again. Here is an instruction that will only continue on if M is equal to 0. Any other value, it's going to go EE, which is down here, and go home and exit. But if M is 0, it's going to continue on down through these other instructions. Since it's only going to do these instructions when the value of M is 0, it means it's only going to do it 1/16 of the time. So we're going to see that M is traveling very fast between 0 and 15, whereas K on this roll, which is going to travel from 0, 1, 2, 3 to 4, then 3, 2, 1 back to 0, it's going to go much slower. So let's execute the application And here we have it set to look at the data. We notice that M is traveling really fast, from 0 to 15 back to 0. Whereas here, K is traveling at 1/16 the speed. It goes 1, 0, 1, 2, 3, to gets to 4, and then it rolls back again. Now let us look at the rest of the program. We have here, it's going to fill the first 10 values in list A with 2. Then it's going to sum up the first 5 values in list A. Well, we know they're all 2's, so the sum of them that gets placed into N should be 10. So let's go execute it again and look for the value of N. N is 10. Back to the program. Below that we say we want the hypotenuse of a right triangle whose both legs are N. Well, we know that to be 10. So let's ask it what the value of P is. We execute it, and here is P, and here's the value. But we notice that there's an E here, which E means to shift the decimal point to the left 5 times, which means this is really 14.14213, which is the square root of 200. Now let's go to the next part. The next part simply says, take the square root of 2 and put it in Q. Alright, we go back and see what the answer is. It says Q's value is 1.414213, which is the square root of 2. You notice again, here's an F, which means the decimal point went to the left 6 times. Now we'll go back to the program again. The next instruction says set R to value of Q and then round R. Well, what we know is here's the value that R was set to, 1.4, but when it was rounded, it was set to just 1. That's the end. Now the program is going to start at tab 5 in subprogram 1. Here the value of A is set to 1, value of B is set to 2. Then it says if they're equal, it's going to go to EF. Well, they're not equal, so it goes to the next one. Branch if not equal. Then it'll go to EF. Well, it should never get the halt because it's either equal or not equal. Once it gets to EF, it says branch if less than AB. Well, it should go to EG. If it didn't, it would branch if greater than or equal to EG. In either case, again, it should never get the halt 2. Then at EG, branch if A is greater than B. Well, we know that that's not true. Well, branch if less than or equal AB. That is true. Then we're going to go to EH. Again, there's no way it should ever get the halt 3. Now we're going to do the same thing for character data. We're going to fill the first 5 characters in line with 65, which is an ASCII A. We're going to fill the first 5 characters of hold with 66, which is an ASCII B. Then we're going to say branch if the test is equal to EI. Well, they're not equal, so won't do that. The next one, branch if the test is not equal the 5 characters at line to hold. Well, that is true, so it's going to go to EI. Of course, it's not going to get to the halt 4. At EI, it's going to branch if the text is less than, line is less than hold. Well, that's true, so it is going to go to EJ right away. The other test was branch if the text is not less than, the 5 at line is not less than hold. And also on this one, there's no way it should ever get to halt 5. Then we have branch if the text is greater than. Line is greater than hold. Well, that's not true. Branch if the text is not greater, the 5 at line is not greater than hold. Well, that is true, so it'll go to EK and go home. So again, there's not ever going to be a halt 6. Well, let's go execute the application, run the trail, and see if it ever halts. Well, there it is. It didn't halt. We'll add 9 more instructions. It didn't halt, and it says it exited without ever halting. So we'll end the trail and this part. While programming, get information from the glossary by clicking Info. Thank you for watching.